Now let's talk about some of the basic geometric objects. The obvious or the simplest geometric object is a point or a planar point. A planar point can be represented by two values, its x-coordinate and the y-coordinate. In general, a d-dimensional point can be represented by d values, d numerical values, x1 up to xd. And the next object we're going to look at is a line. So how can we represent lines? Well, probably if you come from high school, you know you can represent a line in two dimensions using, let's say, this formula. So given two values, a and b, a line is set all the points x and y such that they obey this. So given two values a and b, a point capital X, capital Y is on the line if y equals ax plus b. But that's not the only way to represent lines, and particularly if you remember from your high school, you cannot represent vertical lines using this formula, because like the vertical line, it technically has a slope infinity, so this a should be infinity or minus infinity, I guess, plus minus infinity. So we can't represent it. Using this way, this formulation, we can represent vertical lines. Because if you set, for example, b equals 0, then you get a vertical line at coordinate x equals 1 over a. So if you think about for a moment, is there any line that you cannot represent with this formula? Maybe pause the video and think about this. Yeah, so the answer is the lines that go through the origin. A line that goes through the origin of the coordinate system cannot be represented by this line. The most general way you can have for representation of a line is something like this: ax plus by equals c for 3 parameters. This way of representing line is obviously redundant because it only matters whether c is 0 or not. If c is not 0, then we can divide both sides by c and just go back to this representation. But if c is 0, then we have a representation ax plus by equals 0. And that is essentially all the lines that pass through the origin. Okay. So there are multiple choices to represent lines. And in fact, there are also multiple choices to represent points. This was something that we can go back from here. In other words, if you have two lines, you can have a representation of a point given two lines. So if you have a point P, I could represent P using its coordinates, or I could represent P by the two lines that create its intersection. Since the intersection point of two lines is unique, that's a unique representation of a point. In other words, given two lines, the point P is uniquely determined by these two lines. Also, in general, you could have many complicated representation of a point. So for example, you could have 2 points that define the first line, and you can have another point that define the second line. And now those 4 points define a point that is the result of the intersection points of the two lines that pass through those 4 points. How can we represent d-dimensional lines? Well, again, there are multiple ways to do it. The easiest way, this is not the most economical way, but the easiest way is to represent as 2 pairs of points. So I have a point P1, which can be represented like this, and a point P2. And since from every 2 points we have exactly one line going through, that can be taken as a representation of a line that goes through 2 points. And essentially like this. Okay. There are other objects in chemistry geometry, so we're also going to be dealing with line segments. So line segments again can be represented by 2 pairs of points. A line segment is a piece of a line that lies between 2 points. So given points P1 and a point P2, a line segment is a piece of lines that connects them. There is also a notion of array. So array is a line segment that goes to infinity 0. So array is given by 1 point P and a line that goes through the point P. So it's a line segment where one end is taken to be at infinity. Then there are, of course, circles, can't draw a circle, ellipses. You have degree 2 functions, such as parabolas. You have hyperplanes and higher dimension, and etc. So these are basically most of the geometric objects we're going to be dealing with here. So they could be part of the input or part of the formulation of a particular geometric problem that we want.